All right, let's do another example that's a little bit harder. This time sine squared times cosine squared. Again, no odd powers. I've got to work a little bit harder. And what I'm going to do is apply those identities up there. Now, what I recommend doing in this situation is going over to the side somewhere and do some side work. Because it's all just playing with trig functions. It's not actually doing any integrals for a while. So I guess one way to get rid of the sine squared and the cosine squared is to use those identities, and so let's do that. So the sine is 1 minus the cosine of 2x over 2, and the cosine is 1 plus the cosine of 2x over 2. So I just substitute them in, and now I can multiply that out, and it's not, what I have is a difference times a product. Sorry, difference times a sum. So you know a formula for that. Taking the product of these two things, well, there'll be a 4 in the denominator. And then in the numerator, I get the square of this minus the square of this, right? A minus b times a plus b is a squared minus b squared. So I get that. Well, I'm a little bit happier because at least I don't have two different squares. I still have a square. I want to integrate this. I'm still not in the easy case. I got myself back to an easier hard case. Okay? But we do know what to do about this because I just did it up there. And I could play into this formula that we got, but I think it's just as easy to start to continue to calculate here, use the half angle formula again for this, and continue on your way. So I get a quarter from this bit, and then minus a quarter of the cosine squared of 2x. Okay, now when I plug in 2x in for theta there in the top ord, I'm going to get a 4x on the right-hand side. So it comes out like that. And I guess I could simplify that a little bit more. This is a quarter, oh, but then there's a 2. Here, it's half that. So then I can simplify a little more. It's a quarter minus an eighth, which is an eighth. And then I have an eighth of cosine of 4x. Okay, that's my side work. I just did some trig identities over here and rewrote sine squared times cosine squared as something which involves just no powers of trig, just cosine by itself, and a constant. So I can take that and substitute it in here, and now the integration is pretty easy. 1/8 cosine of 4x over 8 dx, which is, okay, the 1/8 is going to give me x over 8. The integral of cosine is plus or minus the sine. The derivative of the sine is plus the cosine. So it's going to be plus only there's a minus here. So it's going to be the sine minus the sine of 4x divided by this 8, but then I have an additional factor in the denominator, and what's it going to be? I have to put a 4 there. So we've done that calculation too. So any of these, if you keep doing this kind of process, these two kinds of procedures, you can now integrate any expression that has a power of a sine times a power of a cosine in it by using these ideas.